Hello everyone. Hope everyone is doing well. Today we're going to learn about production function, what it is, and we're going to look at marginal product, but we're mainly going to focus on marginal product of labor. So production function, it can be an equation, a graph, or a table that shows how inputs or how much inputs have been used to produce output. So it can be an equation. Now, if I list like what are the inputs to my production, let's say I want to produce, let's say I have a farm and I want to produce corn. So to produce corn, I need land, I need some labor. So I need labor hours. I need some skills because I need to know when to plant the corn, what kind of fertilizer to use, and all those other things. I need machineries. I need seed, fertilizer, insecticides, pesticides, and many other things. So in this case, I would say my output is going to be corn, and my input are all these other factors. So a production function is going to tell me how do I convert all these things into an output. So it can be an equation, as I said, it can be a graph, it can be a table. So, and in microeconomics, we use production functions to see how inputs are converted to output. In macroeconomics, we use production functions to see how all of the economy's inputs are used to produce, let's say, something like GDP. So in our case, let's look at an example. Since there's so many things going into production, we're just going to say, let us hold all the other factors constant and see how changing one factor, let's say labor, affects output. So because all these things affect my input, like I have land, I have skills, machinery, seed, every other things here that I've underlined in green, I'm holding them to be constant, and I'm just changing only labor hours. So I'm just modifying labor hours to see what happens to output. Now, the reason I'm doing this is because if I actually looked at every single combinations of inputs to produce output, it would make a huge table and it would be very, very confusing. So in this case, just to make it simple, I'm saying let us hold all these things constant. Let's say we have 5 acres of land. We can't really increase or decrease land relatively quickly. I need to buy land, my neighbor's land. It might take a while to do that. Skills, let's say my skills during that one harvest period is the same. The machineries, it's the same idea. I might need to secure a loan to buy machinery. So it might take a while to get those machineries, a few months to get the machinery. For seed and fertilizer, if I know how much to use, I already know what amount of seed and fertilizer I need for 5 acres of land. As the same goes with insecticides and pesticides. So it's not really out of the place that I just am varying labor hours and holding everything constant, but it just helps us to understand this concept a little better. Okay, so let us look at a table. So I'm going to insert a table. So let's say labor hours. So how many hours of labor am I using? Or I could also use labor unit, each additional unit of labor that I'm employing. So I have labor hours here. Let's say I could put in 0 hours a day. I could put in 8 hours a day. I could put in 16 hours a day. The way I put in 16 hours is I hire maybe 2 workers. I could put in 24 hours, 36, 40. So these are the labor hours that I have included in my production that I'm considering to add. Okay, and now that's my output. So if I look at this, using this two information, I can draw my production function. So let us draw my production function. So in my y-axis, I should have output, and in my x-axis, I should have labor hours. Instead of labor hours, I could also, as I've said, I could have added units of labor. So it would be 0, 1, 2, 3, 4, 5, 6. Let's make this instead of 36. Let's make this 32. It would be easier. So in my case, then I have labor hours 0. So when I have 0 hours of labor hours, I'm producing 0. So that's going to be the point. When I'm at 8 hours, I'm producing 40 units. So 40 should be somewhere here. So there's my other point. At 16 hours, I'm producing 70. So 50, 60, 70. So it should be somewhere here. At 24, it is 95. So it should be slightly below 100. So it should be here. And then at 32, it is 115. So let's say 10, 15 somewhere is there. At 40, it is 130, somewhere here. And at 48, it is 140. So somewhere around here. So if I drew it properly, it should look like something like that. So this is my production function. It is showing the relationship between input and output. Now, one thing is that if you notice, it's not really a straight line. It should be, and because I did not really draw, the way, exactly accurately, but a production function should actually look like this line. So if I draw it like this, if this is what is that there? And this is labor hours. It should look something like, so it should be bowed. It should be a concave shape, meaning that, as we increase my labor hours, output will grow, but will not grow at a faster rate. It will keep on diminishing as I increase more and more labor hours. So let's see if this actually does that. So I can write change in labor. So I can see that when I'm going from change in labor, I'm going from 0 to 8. So then my change in labor for that unit is going to be 8 hours. Okay, which means I'm just saying how much did I increase my labor hours by? And my output, when I increase my labor hours from 0 to 8 units, output goes up from 0 to 40. So my change in output is going to be 40. Now the next one, when I go from 8 to 16 hours, my change in labor is 16 minus 8, which equals 2. And the change in output is going to be 70 minus 40, which is equal to 30. So I'm going from this to this level. Now the second one I'm doing is 24 minus 16 equals to 8 minus 70 equals to 25. And then 32 minus 24 equals to 8. 115 minus 95 equals to 20. And then 40 minus 32 equals to 8. So as you can see, since I've already calculated them and you know that this is from the change from this level to this level, so let me erase these numbers just to make it easier to see. So as you can see, we are increasing the number of hours by 8. So which means that we are adding one additional person to work in the farm. Now every time we add a person, now let's look at the first one. The first person added, working 8 hours, already is producing 40 units. So this first 8 hours produced 40. The second one, so when I had 16 hours of workers available or work available, I put in 70 units or 70 output. I was able to produce 70 tons or 70 bales of corn. However, the first person was already producing 40. So the second person is only adding 30 to that production. Now, if I go to the third person, the first two people already produced 70. The third person would then basically is producing 25. Okay. So in our case, we are adding each hour of employment, and each hour is having a different increase in output. So we're going to write here marginal product, which is going to be basically my change in output over change in labor. So, or change in input. But in our case, we're looking at labor. So let me just write the equation down here. Marginal product of labor, since we're just looking at labor, so equals to change in output divided by change in input. Here it is. So we have our marginal product. We already calculated the changes. So now we need to just find the marginal product here, which is going to be 40 divided by 8 which is 5. 30 divided by 8, 3.75. 25 divided by 8, 20 divided by 8, 15 divided by 8, and 10 divided by 8. So in our case, then we can see, from here we can see as we increase the number of labor hours, so we are increasing labor hours, the marginal product, that is the output per hour of each worker, is falling as we go. So we can then therefore, we can say then, if I write it here, as we increase the number of workers, the contribution of the last worker keeps on falling, which is telling us, or instead of falling, we can say diminishing. From here, we can talk about law of diminishing marginal returns. So the law of diminishing marginal returns says that if we hold all the inputs the same and increase just one input, here we increased labor, then the contribution of the last unit of input added will diminish, which means it will keep on falling as we keep on adding more. So if I add 2 workers, the marginal product of the first worker was 5 units per hour. It falls to, the marginal product of the second worker falls to 3.75 units per hour. The third one falls to 3.125 units per hour. For the fourth one, it is 2.5 units per hour. For the fifth one, 1.875 units per hour, and the sixth one, 1.25. So this is telling us then, just increasing one factor while holding all the other factors same will lead to the marginal product diminishing over time. Now, why does this happen? Now, let's look at, instead of thinking about farming, let's think about a group project. Let's say you're supposed to do a group project. If you have 2 people working on it, you know exactly what to do. One person can do the research, person can do the writing, and then you can create a product, which may be a paper or a presentation. Now, if you add another person, now you have 3 people, the third person may not have much work to do. But again, you may think, okay, why don't the other person proofread it or do something else in the project? When the fourth person is added, that other person may not even have any more thing to do. So the output is here 1 paper or a presentation. If you keep on adding more and more members in your group, there is less work available for each of them to do. So as a result, each person or the additional worker's contribution to the final paper keeps on falling. So we see that in real life too in many cases, but in our case, we also see that in any kind of production process, we can't just keep on adding workers. When we add more workers, we end up having issues like that. Falling output, or not falling output, falling marginal output. So in other cases, you may be thinking that this marginal product looks kind of familiar. Well, basically it is the slope. So if I draw this production function, the slope at this point will be the marginal product. That's what we are doing because it is change in y divided by the change in x. So that gives me the marginal product. Now, why do we need marginal product of labor? So let's say we have the farmer is thinking, why am I thinking about something like marginal product? Do I really need marginal product? So if you think about each worker, let's say in our case, let's go to the output case here. So instead of looking at labor hours, let's just say labor. So I have 0, 1, 2, 3, 4, 5, 6. So I'm thinking about hiring 6 workers, and this is my output. So the change in labor in all my cases is going to be 1. So I'm increasing the number of workers by 1, and this is my change in output. So the reason why, when I think about why should I hire an additional worker, if I hire this worker, let's say I have to pay each worker $100 a day. So the wage is, let's say, $100 per day. So if that's the wage rate, and let's say per day they're producing, let's say I'm going from 2 to 3 workers. So to hire the third worker, I need to pay that person $100. Now, let's say the third worker's contribution is 25 units. Now, let's say the price is, if this is a price-taking firm, the price is. So if that's the case, then the revenue will be equal to 4 times 25, which equals to $100. So it means that I'm paying this person $100 and I get $100 of revenue. So in this case, I would be indifferent to hiring this third worker. But let's say, what about the fourth worker? Should I hire another worker? If I hire the fourth worker, I still need to pay $100 a day. So this is true. Now, what about the contribution of the fourth worker? The contribution of the fourth worker is 20 units. The fourth worker is only producing 20 units, and I still have $4 to produce, or I still charge $4 per unit because that's the market price. So then my revenue is going to be, so it's the $4 times the 20 units, which is $80. So if you notice here, my cost is 100, my revenue is 80. So here my revenues is actually less than my cost of that fourth worker. So revenues from the fourth worker is less than the cost of wages of the fourth worker. So in that case, I will not hire this fourth worker. So this fourth worker should not be hired. Third worker, I should hire. What about the second worker? Second worker is producing 30 units. So if it's $4, so 4 times 30 would be $120. I pay $100 to that as wages. So this makes sense. So I should hire the 20th or the second worker, and I should also hire the first worker. But I should not hire the fourth, fifth, or sixth worker because their contribution is less than the cost of hiring them. So marginal product helps us to see that, is that where should I hire, or at what level should I continue hiring? So in our case, we should only hire up to the third worker. We should definitely hire 2 workers, and third worker, we are indifferent. I mean, it seems like more production is nice, so we probably can hire up to the third worker because this is happening. So this is why marginal products are important. It helps us to find out up to what level of input should we hire to continue our production. Okay, well, that's all we have for today. If you have any questions, please do feel free to contact me and by writing a question below in the comments, and I'll see you at a later video. Goodbye.